Hello friends, welcome to my channel. In this video, we will discuss SSC JE 2020 solution. Exam date was 11th December 2020. Morning shift, first shift, 10:15 AM paper we will solve. This is part 6 of this video series. Question 169 onwards we will discuss. Only technical part. Question is, if metacentric height of a floating object is positive, the object will be dash. Whether it's in stable equilibrium or neutral equilibrium or unstable equilibrium. So metacentric height we know first. This is your center of buoyancy B, then G is your center of gravity, then M is your metacenter. If M is above G, we will get like this. Then Gm equal to Bm minus Bg. Metacentric height is your Gm. It's positive case, so you will get like this. M is above G. You will get metacenter in floating objects only. If a object is floating like this is the object. This is its axis. Center of gravity you will get somewhere here. Then force of buoyancy. If you tilt the body, it will shift B point, center of buoyancy point. This one G point, center of gravity. It will act, force of buoyancy act upwards, where it will cut the axis. That point is your metacenter M. Metacenter is the point where force of buoyancy or FB cuts the axis of the body after tilting. So M point is your metacenter point. In 3 cases we will discuss whenever 1, 2 and 3 cases. G is above M and M is above G, then M and G at same point. M is above G, this is your positive case, stable equilibrium. G is above M, you will get negative, unstable equilibrium. Then neutral equilibrium, G is your Gm or metacentric height, it will come 0, neutral equilibrium. Already discussed, Gm equal to Bm minus Bg. So it's a positive case. Metacentric height of floating object is positive. So M is above G. It's stable equilibrium. Next question. If the velocity of flow at a particular point or at a section does not change with respect to time, then the flow is known as particular point at a section with respect to time. So velocity of flow dv by dt with respect to time, it's equal to 0. We know with respect to time means it's steady flow. If it is with respect to space, dv by ds equal to 0. With respect to space means this one time. in case of steady flow. And if it is with respect to space, the velocities remain unchanged. With respect to space means it's uniform flow. So does not change with respect to time. Steady flow. If it will change with respect to time, then unsteady flow. Laminar flow, layer by layer flow, smooth layers, one layer is above, like this, then it's laminar flow. Turbulent flow, it's a zigzag path. It will cut like this, then it's turbulent flow. Then again similar question from your buoyancy. In a floating body, the buoyant force acts through the center of gravity of the displaced volume of the fluid is termed as. It's a floating body. This body is floating. G is a center of gravity of the body, and B is center of gravity of the displaced fluid. CG of displaced volume of the fluid. B point, force of buoyancy point. Yes, force of buoyancy, it will act upwards. Floating body FB or force of buoyancy acts through the center of gravity of the fluid displaced. So in this question, in a floating body, the buoyancy force acts through the center of gravity of the displaced fluid is termed as center of buoyancy. A is your correct answer. Metacenter already discussed. Center of gravity is the center of gravity of the body. G point, center of gravity point, this one. Then gamma iron has structure of gamma iron structure. First you will get alpha iron, magnetic, up to your Curie point, 768 degrees Celsius. Then up to 910 degrees Celsius, beta iron, non-magnetic. Above, at Curie point, your magnetic properties will change. Means if you heat it, then it will become non-magnetic, and if you cool below Curie point, then it will become magnetic. Then this one BCC structure. Then beyond 910 degrees Celsius, you will get gamma iron, FCC structure. Then you will get (1410 degrees Celsius), you will get again BCC structure. So gamma iron FCC structure. A is your correct answer. And BCC structure, your delta iron and your alpha iron. Next question. For fluid, the shear stress is directly proportional to how much? So Newton's law of viscosity, tau is proportional to d theta by dt. D theta by dt is shear strain rate. Shear strain rate or rate of change of angular deformation, rate of angular deformation. Rate of angular deformation, or tau equal to dv by dy also you can write. This one is your velocity gradient. Then tau equal to mu into d theta by dt, or it's equal to mu dv by dy, velocity gradient. This one is your coefficient of viscosity. Coefficient of viscosity, or your absolute viscosity, or your dynamic viscosity, whatever you want to write, you can write. Answer is C, strain rate. Strain rate. Fluid shear stress is tau. Tau is directly proportional to strain rate d theta by dt. Then next question. If stress measuring device shows reading as 1 megapascal, it's equivalent to how much? So we know 1 pascal is your 1 Newton per meter square. Then megapascal, 1 megapascal is 10 to the power 6 Newton per meter square, or it's equal to 10 to the power 6 Pascal. 10 to the power 6 Newton per 1 meter is 10 to the power 3 mm. Its square, how much you will get? 10 to the power 3 divided by 10 to the power 3 Newton per mm square. So 1 Newton per mm square. From option we will check 1 megapascal, it's equal to 1 Newton per mm square. One more thing also important here. 1 bar equal to 10 to the power 5 Newton per meter square. And question number 175. The pressure ratio known as critical pressure ratio for maximum discharge through the nozzle is given by how much? Choked condition. All three are important. Pressure, temperature, density. Rarely they may ask. Exams like ISRO, they may ask. Otherwise, maximum time they will ask for temperature and your pressure. Choked condition or maximum flow rate condition. So we will start from temperature. T star by T1 2 by n plus 1. If you go for pressure, T star by T1, this one is for temperature ratio. Then P star by P1 2 by n plus 1, it will remain as it is like temperature. Then your power will change, its power n minus 1, this one for critical pressure ratio, this one for critical temperature ratio. Sorry, this one P1. Then for density also you will get. Exams for ISRO technical assistant, they may ask for rho. Otherwise in other exams, maximum times they won't ask with this regarding the density. Power will change 1 by n minus 1. This one for critical density ratio. So they ask for critical pressure ratio, this one. P star by P1. And your T1, P1 and rho 1, these are temperature, pressure and density. And for your critical condition, P2 equal to P star. You can write P2 by P1, it's equal to P star by P1 2 by n plus 1 whole to the power n by n minus 1. So from option we will check 2 by n plus 1 whole to the power n by n minus 1. A is your correct answer. For critical pressure ratio, P2 will become P star. Then next question. Lead screw of a lathe machine is example of dash pair. Theory of machine question. Its screw pair. Lead screw of lathe machine is an example of dash pair. Two rods you will get horizontal, one feed rod and one is a lead screw. You have to check which one is. I am not sure whether your feed rod is above lead screw or lead screw is above feed rod. That one you have to check. But if you stand in front of the lathe machine, two rods are visible, horizontal rods. In lead screw you will get threads, and feed rod you won't get threads. Lead screw and your knot, screw pair or helical pair. Screw pair available here. So answer is B. Two mating links have turning as well as sliding motion between them. Lead screw and knot of lathe. TTT curves are dash curves. ISRO technical assistant. This one is your famous question. TTT curves. These are isothermal curves. You just remember TTT curves are isothermal curves. Temperature, time or transformation. Temperature, time, transformation. Or time, temperature, transformation. Curve or Baines curve. They may ask this one also in Baines curve. Baines TTT curves are dash curves, isothermal curves.